I've come up with another set of confusing terms from carbohydrates. Hello, my name is Dr. Kamya Tikku, and today we are going to discuss epimers versus enantiomers, stereoisomers, and anomers. So let's understand the differences between them. So while studying the monosaccharides, you must have came across lot of structures like hexoses, pentoses, trioses, tetroses. So now what are epimers? We learn for all of them. So an epimer is an isomer that differs only at one carbon location. So in case of epimers, they differ only at one carbon. For example, D-glucose and D-galactose. So D-glucose and D-galactose, both of them are aldoses. They differ only at carbon number 4, 1, 2, 3, 4. H-OH differences are there. Second, we have enantiomers. Enantiomers are also called optical isomers because they are mirror images of each other. That means if you see D-glucose in mirror, it will look like L-glucose. And they are non-superimposable, just like our hands. So D-glucose have OHH, OHH like this on right-hand side, whereas L-glucose has mirror image. The reference carbon is showing OH on the right-hand side. That's why it's a D-glucose. Whereas in this case, reference carbon is showing OH on the left-hand side. That's why it is L-glucose. Stereoisomers. So in this type of isomerism, molecules have same molecular formula and sequence of bonded atoms, but they differ in three-dimensional orientations of their atoms in space. So to understand stereoisomers, let's understand that isomers can be of two types: structural isomers, which are also called constitutional, and stereoisomers. Now stereoisomers, because this is an umbrella term, they can be distereoisomers and they can be enantiomers. Enantiomers, we just learned that D and L forms, which are usually non-superimposable and mirror images of each other. Whereas diastereomers, for example, cis and trans form, they are opposite. They are superimposable and they are non-mirror images. Last, we have anomers. Anomers are usually isomers for the cyclic forms. So when we convert the linear form to the cyclic form, during that conversion, cyclic monosaccharides, they differ from each other in the configuration of carbon number 1 in case of aldoses and carbon number 2 in case of ketoses. So D-glucose can be written as alpha-D-glucopyranose or alpha-D-glucose if OH is at the bottom for the first carbon. And it can be written as beta-D-glucopyranose or beta-D-glucose if OH is on the top in the C1 carbon. That's all for the video. Thanks for watching. Stay tuned for such more terms and important videos. Do subscribe to my channel. Thank you.